The first time you digitize a heavy machine, that green light on the sensor feels like a victory. It is proof that the connection works and the data is flowing. Executives often see this single success as a finished product. To a CEO, if one machine works, 50 should work by Monday, leading to orders for an immediate factory-wide rollout. Siam Canned Food followed this exact impulse. Following a successful pilot, their electrical team spent a single weekend installing 20 IoT sensors across the floor to meet an aggressive corporate deadline. This creates a dangerous false confidence. A single success masks the complex operational friction that only reveals itself when a system is forced to handle significant scale. Monday morning, 20 machines were turned on simultaneously. The server was instantly overwhelmed by the blast of data, crashing the system. Hardware limits appeared next. Node 15, an older, high-moisture machine, immediately short-circuited its sensor. The factory environment simply wasn't uniform. Workers quickly abandoned the broken screens to return to their manual logs. Frustrated by the chaos, the CEO was forced to kill the entire digital initiative. Scaling digital technology exponentially multiplies the hidden variables that will eventually fracture any rigid system. When the business diagnosticians arrived to analyze the crash, they found a missing step. The company had failed to account for a phase of intentional, managed failure. For a century, factory managers viewed mistakes as something to be eliminated from the assembly line. In that traditional mindset, errors signify inefficiency. The digital Kaizen mindset flips this logic. A broken sensor or an oil-smudged touchscreen is high-value data that tells you exactly how the system needs to be hardened. Discovering a moisture vulnerability on one machine during a pilot saves the company from purchasing 50 sensors that are destined to fail. Intentionally breaking a system early and logging the anomalies is a strategic asset. It immunizes the wider rollout against the kind of catastrophic loss seen at Siam Canned Food. To expand safely, you apply the Toyota concept of Yokoten. This is the systematic transfer of every technical fix and operational adjustment from the pilot machine to the rest of the fleet. This requires a phased rollout. You move from one machine to a 5-machine cell, then pause. These deliberate pauses reveal infrastructure bottlenecks, giving your IT team time to expand network bandwidth before the growing data load crashes the server. You also need a decentralized training plan. Since 2 IT specialists cannot train 500 workers, the original pilot operators must be converted into super users who can teach their own peers. Yokoten converts the risk of full-scale deployment into a series of predictable, manageable stress tests. In Industry 4.0, projects must only advance based on systemic readiness. Arbitrary executive timelines are secondary to the stability of the system. Run the checklist. Does a failure log exist? Is the network ready for a massive data increase? Is the playbook written by the technicians who actually ran the pilot? Is there a train-the-trainer hierarchy in place? And finally, is the current phase completely stable before you think about the next one? Rushing a deployment to hit an artificial end-of-month goal is a leading cause of death for digital transformation projects. Reid Hoffman, the founder of LinkedIn, argues that if you aren't embarrassed by the first version of your product, you launch too late. A perfect day-one system is simply impossible. Resilient digitization is built exclusively through the technical scars and lessons earned during the pilot phase. A resilient, smart factory emerges through the systematic compounding of lessons learned from early, ugly failures, turning a fragile pilot into a system capable of continuous scale.